Our presentation today is about our project to create a temperature and humidity controller for a lizard habitat. We'd like to thank Dr. Hennegran for the opportunity to present our research, and of course to our friend Wilbur the lizard for his cooperation with our tests. We are three senior chemical engineers at BYU familiar with process control principles and lizard needs.
Chinese water dragons, which Wilbur is, as it turns out, are not from Utah. They're from China. China has a rather different climate where these lizards live than Utah. It's a jungle and Utah is a desert. So it's necessary to have pretty tight control over temperature and humidity to keep the lizard happy. There's a variety of controllers on the market that can control temperature and humidity, but we wanted to create one with a feed-forward element to improve the response.
Before we could design our controller, we needed to run a couple of experiments to see how temperature and humidity responded to different conditions that we had available. So here on this slide you can see a representation of our experimental setup. So on the right, in order to manipulate the temperature, we would use heat lamps, and depending on the number of light bulbs that were turned on, we were able to manipulate how much heat was entering the cage. For the humidity, we were able to manipulate the humidity depending on the flow rate of water which we allowed to flow through the humidifier. Here in the middle of the cage you can see the sensor, and that was placed there because that is Wilbur's basking area and where he spends most of his time, so we just wanted to optimize the temperature and humidity there. We also were able to introduce a disturbance to our system by turning on the fan in the room, and when we ran those tests, we were able to see that the humidity was the only variable that responded significantly to turning on the fan. The temperature didn't see a very large change, and so we decided that a feed-forward element would only be necessary with the humidity controller.
Using the collected data, we developed an FOPDT model for each system. The temperature required two different PID controllers because the time constants were very different, whether the temperature was rising or falling. Here we see the block diagram of our controllers in Simulink. Notice here up top is the feed-forward element added to the humidity controller, and down below on the temperature controller, the two PID controllers. Also in the temperature controller, a simulated MATLAB function was used to gradually switch between the two PID controllers when approaching a set point, whether it was rising or falling.
Here are graphs of our controller response. You can see the untuned response is rather sluggish, takes a while to get to the set point. So we want to improve that, as the lizards are pretty sensitive to changing temperatures, so you want to keep it right around the set point. To do that, we increase the gain to give an overshoot of about 5% on the temperature response and decrease the rise time as much as possible. The humidity response wasn't as important, but we still gave a little bit of overshoot to improve the rise time.
We are happy to report that we were able to successfully design a controller that will allow for even more precision in optimizing the habitat for our cold-blooded friends. As we noticed in our testing, the disturbance from the ceiling fan had a significant impact on the humidity, and therefore we recommend to every lizard lover that they look for a controller with a feed-forward element. So we'll see if we eventually get ours out on the market. And we'd like to thank you for listening to our presentation and hope you have a great day.